to start our calculations. First thing we need to do is to calculate p hat, and the formula for that was x1 plus x2 divided by n1 plus n2. The only trouble in this example is that, going back to our data, we weren't given the x's. Say, for instance, the x1 and the x2. We know what n1 and n2 are, we know what the proportions are, but we weren't given the x's. So we have to work those out. So let's do that over on the side here. So we have that p1 hat is calculated by formulas in x1 divided by n1, and we know what n1 is. That's 232. And the result was given us as 25%. So rearranging that formula, we'll have that x1 is equal to 232 times 0.25. Let's go to Excel and work that out. That's equal to 232 times 0.25, and that's 58. Remember that the x's have to be whole numbers. Alright, so this is the number of people. 58 people in that group of 232 had this as their primary desire. And then going to p hat 2, the formula for that is x2 divided by n2. We know what n2 is, so this is x2 divided by the n2 of 106, and the result that was given to us is 0.198. Again, so rearranging that, we can have that x2 is 106 times 0.198, and going to Excel to work that out, 106 times 0.198 is the number given here, 20.988, but remember that x1 must be a whole number, so this must be 21. Go to the nearest whole number. Okay, and there's got to be the one that is close. So going back to p hat, we have x1 is 58 people in the first group that had this as their primary desire, 21 people in the second group, okay, which adds up to 79, and n1 232 plus n2 106, and that's 338. So 79 divided by 338 is 0.2337. And as I've said in the previous section, this answer must be between the two individual proportions, in this case p hat 1 of 0.25 and the p hat 2 of 0.198. Alright, our 23% is between the 25 and the 19, so we're inside that range. So we're not obviously wrong. We've done our check. Next step is to do the standard deviation, sigma hats, so p hat 1 minus p hat 2, and this is square root of p hat times its complement, 1 minus p hat, times 1 over n1 plus 1 over n2. Remember, it's the square root of the whole thing. And that'll be equal to 0.2337 times its complement, 1 minus 0.2337 times 1 over n1, 232, plus 1 over n2, 106. And let's extend the square root sign over the whole thing. And let's go to Excel and work that out. So this is going to be the square root of 0.2337 times parentheses 1 minus 2337, close parentheses, open up a new set, times 1 divided by 232 plus 1 divided by 106, close the parentheses for the first, for the last calculation, and then for the square root, and the answer is 0.04961. 0.04961. The 0.04961 is our standard deviation. And now we can finally do the z-calc, which is the sample difference, p hat 1 minus p hat 2, minus the hypothesized difference, p1 minus p2, which is always 0, divided by the standard deviation, sigma hat, so p hat 1 minus p hat 2. Alright, so the sample difference was the 25% minus the 19.8%, so 0.25 minus 0.198, minus the hypothesized difference, 0 divided by the standard deviation, 0.04961, and the answer to that is, go to Excel again, so parentheses 0.25 minus 0.198 divided by the standard deviation, and that's 1.048. 1.048. Okay, and the z-calc of 1.048, let's go back to our diagram, is in the right smack in the dab in the middle of the acceptance region, so we go with the null. Alright, cannot reject the null. There's an insignificant difference between the two groups. So our decision will be as follows: since z-calc is 1.048, and since that is between the critical values on this two-tailed test of plus and minus 1.96, do not reject the null. And the interpretation there is an insignificant difference between two groups of older people, older customers. And that's the end of that problem.